if we consider interrupts means in the embedded system. So when the embedded system is executing, right? So when it is at a running condition, um, if some changes happen, so if some change happen, how the system would respond. So that is one of the main thing. So therefore, almost all the real-time applications, so they are implemented using this feature called interrupts, right? So um, I will show you the example as well, right? So if you understand what is an interrupt, right? So as the name suggests, interrupts are special events that require immediate attention. Right? So it stops a microcontroller or microprocessor from the running task and to serve a special task known as interrupt service routine. We call it as ISR or interrupt handler. Right? So what is meant by this is actually um, so the microcontroller, it is in running, right? Then when this interrupt happens, it will go from the regular task to another task which is called interrupt service routine, right? Or interrupt handler. Then it will execute the tasks at that ISR or interrupt service routine. Okay, so we'll understand this one by an example, right? So suppose you are at home taking coffee. Uh, Suddenly your mobile phone rings, right? So what you would do is you would stop taking coffee and answer the call, right? So when you have finished the conversation, so you will go back to take coffee, right? So, so if we imagine what is this, so you at home, so you are taking a coffee, so that is your normal task. But suddenly, when your phone rings, what you will do is you will attend to your mobile phone by stopping what you were doing up to now, that is taking coffee, and you will answer the call. But after the call finishes, you will get back to your coffee, right? So that's how this happens, right? So this process is similar to ISR execution. So you can think the main service routine as taking coffee, right? So the main service routine is, or the normal condition, or the main service that we are doing is, or the main routing is taking coffee, right? And the ringing of mobile phone, that is the interrupt that we are getting. And uh, and uh, um, and uh, the, and what we are doing in the that means after that we are going to attend to that mobile phone conversation. So that is similar to executing the ISR. So what is meant by ISR? Interrupt service routine, right? So there are two routines. So first one is the normal routine that we are already doing, but when an interrupt happens, we will go to another task which is called ISR, interrupt service routine. Then after we finish the business in there, we will come back to the main routine, right? So when the mobile conversation is ended, you will go back to the main service routine of taking coffee, right? So we had the main service routine, then because of an interrupt we will go to interrupt service routine, but after finishing what is at the interrupt service routine, we will come back to main service routine, right? So with this you can understand what is an ISRO, what is happening in interrupts, right? So anything that is taking you from your normal operation to the interrupt service routine, that is called an interrupt. Okay, mm, so why we need interrupts, right? So if we talk about why we need a interrupt, so we'll consider a MP3 player which built around microcontroller. It contains push button switches to select song, control volume, etc. So here you have my MP3 player. So it is built using a microcontroller. So it contains push buttons. So where we can give inputs. right? So what are the inputs that we can give? We can select songs, we can control volume. Likewise, so there are a lot of inputs that we can give. Then the microcontroller should be programmed to convert the data stored in MP3 files to electrical signal and to change controls according to the status of the push button switches, right? So, um, so thing like this. So when we have the MP3 files, right? Uh, so when we have MP3 file, so it should be converted to electrical signals, right? Electrical signals, and it should be played. Right? So now let's say our MP3, that MP3 is playing. So therefore, afterwards, what you have to do is when your MP3 file is converted to electrical signals and when it is playing, right? So using the controls, um, you can change or you can take the control of that. You can, that means you can adjust the volume, you can select songs. So likewise you can do lot of controls in there, right? So therefore consider this application without interrupt, right? So the programmer wants to continuously do the following task, right? So let's see. Read the status of push button switches and change controls accordingly, right? Read data from mp3 file, convert it to electrical signal, right? uh, so can you understand this? uh, so whenever mp3 player is working, when our mp3 player is working, that means let's say there's a song playing, right? There's a song playing, right? So then think that there's only one control which is called controlling the volume, right? Controlling the volume. But when we control in the when we control in the volume, right? When we control in the volume, what should happen is um, uh, um, the microcontroller, it should take a look at, right? It should take a look at the status of this volume controller. um, Periodically it should take a watch on it should watch what is happening in the volume controller. Can you understand? So yeah, that's why it says read the status of the push button switches and change controls accordingly. So that should be done by the um, microcontroller each and every time, right? Each and every time. Then what should do? It should read data from mp3 file, right? Then after reading it, it should convert it to electrical signal as well, right? So these are the tasks that we have to do if we are doing it without interrupts, right? That means um, uh, here mp3 player song is playing and we have only one control, which is volume controller, let's say. So then periodically uh, periodically the microcontroller, it has to read the status of push button switches and change controls accordingly. It should read the status of push button switches and change controls accordingly. So in order to do that, it should read the status of the button or the volume controller, like let's say for 100 milliseconds it has to take a look, or let's say 1 second. For each 1 second it has to take a look. So what is the volume controller value, what is the volume controller value? So like that it should always monitor that one. Then it has to, so this is our main program, which is read the data from mp3 file and convert it to electrical signals, right? So that is our main program. So if we are doing it without using interrupt, so this is how we have to do, right? But um, uh, okay, so yeah, this process of continuous monitoring is known as polling, right? So this is not an efficient way of programming as it consumes all its processing time for monitoring, right? So can you understand that if we in here I have talked about only volume controller, but there are many controls, right? So there are a lot of push buttons. From those push buttons, you are getting lot of a lot of input. So if you are going to monitor more than more than one, then it consumes more time, right? right? So if we have to, right, control if we have to control control all those controllers. So in here I have talked about only one control, but if when there are a lot of controls, so the microcontroller has to spend its processing power in order to do this monitoring, or what we call as polling, right? So actually this is not an efficient way because it consumes the processing time for monitoring. So um, therefore, in when we are writing the program, we will consider the inputs from these controls as interrupts, right? As interrupts. So the main operation will go, but at the meantime, what will happen is, not at the meantime, at the same time, if someone push a button, right? So it will take it as an interrupt, then it will go to that program execution, right? So we are not monitoring continuously. We will act only when we received an interrupt, or when we receive an input, that time only we are acting. So otherwise we will executing our program. So therefore, in the microcontroller in normal condition, it has to spend its processing power and processing time only for this: read the data from mp3 file, then convert it to electrical signal. That's the only thing that it has to do. We don't have to monitor because we are using the interrupt functions, right? Okay, so the main thing is the microcontroller wants to respond only when the interrupts occurs, right? Only there is an interrupt, that time only the microcontroller will respond. So otherwise it will execute its normal operation, right? So that is why we need interrupts, right? Mm. So here consider if we consider an example of polling. So the method of polling is similar to a salesperson, right? So salesperson, so yeah, who goes door to door to request to buy his product or service, right? So like that, we will continuously go and we will continuously. Yeah. The salesperson, he will continuously go door to door, right? Request buy his product or service, right? So it is like the monitoring process. So this is similar to microcontroller continuously monitoring the status of all devices attached to it. Right? So as I have told you, there are a lot of devices attached to microcontroller, or a lot of inputs, let's say. So then, or controls. So at that time, if we are using the method called polling, so the microcontroller has to monitor, or it has to do polling at each and every time, in order to find out the status of that control, right? But uh, but that is not the effective way, right? So while the method of interrupt is similar to shopkeeper, right, whoever needs his product or services goes to him and buy it, right? So that you have to understand, whoever needs the product, he will go him to buy it, right? So he will go to him and buy it, right? So this is similar to microcontroller's response only when an interrupt occurs, right? So uh, um, if we are in interrupts, microcontroller only responds when there's an interrupt occurs. So that is the difference. But in here, in the polling method, it will continuously monitor the status, so then it will respond, right? So in both times the microcontroller will respond, but in the interrupts method, it will respond only when there's an interrupt occurs. Otherwise, in the previous method, it will continuously monitor the status of all devices, so which will consume the microcontroller processing power and the time. Okay. uh, so here, if we consider there are two types of interrupts, right? When we are talking about the big microcontrollers, so there are hardware and software interrupts, right? Hardware and software interrupts. So you may have remember some of the interrupts, right? So I will brief you, right? If the interrupts are generated by external hardware at certain pins of microcontroller, or by inbuilt devices like timer, they are called hardware interrupts, right? So if you can remember that, when we are talking about the timers, right? So when or timers and counters, so when a timer, right? So if you can you remember that watchdog timer? In that watchdog timer, when that watchdog timer completes, what it does is, when we have all enabled watchdog timer, when it completes, it will generate an interrupt, and that interrupt will execute the program from the beginning. If you can remember from the last time I talked about the watchdog timer, in watchdog timer, what it does is actually, when it is completed, what it does is it will generate an interrupt, and that interrupt will cause to the program executes from the beginning. Okay, from the beginning. So they are like hardware interrupts. So what is software interrupts? So software interrupts are generated by a piece of code in the program, also known as external and internal interrupts. So we can write for interrupts, or we can program in for interrupts. That means we can write a code in order to generate interrupts, right? So today we'll take a look at an example also using interrupts, right? I will introduce another microcontroller to you. This is PIC16F877A, right? um, when we are changing the pick and everything, so you don't have to worry, because everything looks same, but we are changing it, because then you will get some more understanding about what needs to be done, right? So that's why. So interrupts in PIC16F877A, right? So here, uh, in this PIC, there are 15 interrupt sources, right? So one is external, and the timer 0, timer 1, RB port change, parallel save plot read and write, AD converter, U USART receive, USART transmit. So there are many interrupt sources, but what we'll today look at is how we can give an interrupt by uh, externally. Right? We'll take a look at that. Uh, in the data sheet of PIC16F877A, you will see those things. Mhm. Okay, so uh, in order to control the operation of interrupts, we are using these mm, um, registers inside the microcontroller. So this is intcon, so that is the interrupt control register, then PI1, PIR1, PIE2, PIR2, right? Um, so today what we are going to do is we will consider in external interrupts, right? External interrupts. So when we are considering external interrupts, we'll take a look at how the intcon register is configuring those interrupts. So in order to configure external interrupts, we need this intcon register, right? So here there are like many interrupts. No? Here you can see there are many interrupt sources, so 15 of them. So therefore the other registers, they are used to control those things, right? But using intcon register, we will do some example on external interrupt. Okay, so here this is the intercon register, right? Yeah, interrupt control register. So how many bits? It has 8 bits. So bit 0, 1, 2, 3, 4, 5, 6, 7. There are 8 bits, 8 bits, right? We'll see one by one uh, uh, the bits that we need to change when we are using an external interrupt. Okay. Okay, so I will show you what we are going to achieve, right? Right, hope right, all of you can see this, right? So this is PIC 16F877A, right? And here this is the oscillator part, so you know already this is the oscillator part, right? And using this battery, 5-volt battery, I'm supplying the 5 volts to here, right? And mm, yeah, okay, 5 volts to here, right? Using this one we will supply 5 volts to this point. Then here using this line I am supplying um, I'm supplying the required voltages, right? So VDD, where is VSS? Yeah, I'm not showing VSS, huh? So don't think about this. So like consider it like this, right? So here this is the one that I need, right? So it is considered to the here RB0 INT, right? So this is where we are giving an input, right? So can you tell me what will happen here when we are not pressing this button? What is the value on this RB0 pin? What is the voltage value on this RB0 pin when we are not pressing this, right? This push button is not pushed, right? It is open, right? So at that time, what is the voltage at this point? We run it as well, right? The voltage at this point will be, here it is 5 volts and here it is 0 volts, right? So you can see so on RB0 pin the voltage will be 0, right? So can you see that in this um, uh, blue color? Can you see blue color means here the other sign, can you see this sign, ash color? So ash color means they are floating, either they are not either 0 or 5 volts, so they are floating, right? So they don't have a voltage. So don't have voltage is not um, 0 volts. 0 volts means applied 0 volts. 0 volts is, it is also an voltage, right? But in here we don't have voltage, so that's why here these ones RB1 to RB7, and here the other places are they in floating mode, right? So when we are not pressing this, it is at 0. But here what we are doing is this push button will provide an interrupt to this PIC 16F877A. Right? So for PIC 16F877A, this will provide an interrupt. That means when we press this, this will become 5 volts. Right? So yeah, this is the initial condition. So what is the initial conditions? Here I am connecting for this is how many ports that we have in here. Can you see? Yeah, port B, right? Yeah, port A, port B, port C, port D, and here port E as well. It has only 3 bits, 3 bits, right? So port A, port B, port C, port D, port E, right? Here this is 8-bit, 8-bit, 8-bit. Here this one, this is 6-bit, right? Here this is 6 bits, and here this one 3 bits. Right? So how many input outputs that it has? 8, 8, 8, 24, 27, 633, right? Like that. So this is the normal operation. What is the normal operation? We are providing the these LEDs are switched on. That means the LED is connected to RC1, RC 3, RC5 and RC7. They are switched on at the normal operation. So this is the normal operation. Are we applying an interrupt in here? No, right? So this is what we call the normal operation. So what I have done is I have written a program in order to what we call, in order to, when we run this program, right, when we when not run, when this interrupt occurs, the input sorry the output of this port C, it will toggle means here this is the initial condition. So when an interrupt occurs, that means when I push this push button, what it should do is it should toggle means um, here RC0, RC2, RC4, and RC6. So these are actually switched off, right? So switched off one should be switched on one should be switched off, right? So that is how we are going to write the program to this, right? So when we give an interrupt in here, right? When we give an interrupt in here, this should switch on, this should switch off, on, off, on, off, on, off. That means this one and this one, it should switched on, and this one and this one, that means D1, D3, D5, D7, they should switch off, right? So that is how we are going to write the program. So I will show you how it works. So when I press this, I will provide an interrupt. So can you see? So here, can you see? So when I provide this interrupt, right, I'm not pressing it, right, I will just provide it once, right? When it happens, what happens? This has switched on. But can you see this, why we call this as an interrupt? Because after that interrupt, it will go back to its normal condition, right? So what is the normal condition? In normal condition, D1, D3, D5, and D7, it should switched on. Can you understand? D1, D3, D5, and D7, they should be switched on, and D0, D2, D4, and D6, they should be at switched off stage, right? Can you understand? They should be at switched off stage. So this is our normal condition. But when an interrupt occurs, so I have written the program. Right? So you haven't written the program, you haven't seen the program. I will show you before we are doing it, right? So when we give an interrupt from here, so that's why it is called interrupt. When I give an interrupt, so at that time only, for like 1 second. So what I'm doing, I have programmed it like, when we give an interrupt for 1 second, switched all the switched off one should be switched on one should be switched off. That means the output should toggle. So that is what I have written in the program. So at that time, okay, at that time, what should happen is, um, after finishing that interrupt operation, it should come back to the normal operation. So it is like, so we are in the normal condition, then when an interrupt occurs, we will go to that interrupt operation, which is called ISR. But after that, we should return back to the normal condition, which is this, right? So let's say if I just press it, right, then these values are keep on stage. So if it is at kept on stage, that is not an interrupt. Can you understand? So previously, if you can remember, when we have written that when we give an input, when we give an input, one bulb is switched on, and it was at switched on stage. It didn't return to the normal condition, right? So that is not an interrupt, but this is an interrupt. Here, when I press this, at that time, for like 1 second, that's how I have written, for 1 second, these has switched on, but after finishing that ISR or interrupt service routine, it has returned back to the normal condition, which is this, right? So that's what we are going to do, right? So again, let's see how it should be done. So in order to handle external interrupt, so here, what we had in here is this, an external interrupt. So external interrupt, we require only this intercon register, right? So here we have 1, 2, 3, 4, 5, 6, 7, 8 bits, right? 8 bits. So we will see how it works. So GIE, the bit number 7. So it is global interrupt enable bit. So encode register is readable and writable register which contains various enable and flag bits for external and so uh, this encode register we need it for both external and internal interrupts, right? External and internal interrupts. So but in order to configure external interrupts we require only this encode register, right? So here we don't have to worry. So if you take a look at the data sheet of this PIC 16F877A, right? So for other PICs also we have that interrupt operation, right? Interrupt operation. So I'm just introducing you a new PIC because then you can get more, can cover more area on PIC microcontrollers, right? Um, So here, first of all, GI global interrupt enable. So one, enable all unmasked interrupts. Zero, disable all interrupts. Right. So that's correct. So then, peripheral interrupt enable. That means enables all unmasked peripheral interrupts. Disable all peripheral interrupts. So what is meant by peripherals means the things that we are connecting to the microcontroller from outside. Right. So those things we call as peripherals. Right? Peripherals means the things that we are connecting outside. So if I make this pin 1, then it will enable all peripheral interrupts. The next one, timer 0 overflow interrupt enabled. So here timer 0 interrupt is when a timer goes up to its maximum value, then it will generate an interrupt. But in here we don't need this timer 0 interrupt enable because here we are using external interrupt. Then next one, in INTE or RB0 INT external interrupt enable. So here uh, uh, so if you can remember, I have shown you we are connecting our push button to this one, RB0 pin or interrupt pin. So therefore um, when I make it 1, then it will enable interrupt through that pin. Then RB port change interrupt enable. So here we are not going to change any port, so therefore we don't need that one for this operation. Right. Then here next one for timer 0 overflow interrupt flag, right? Then INTP external interrupt flag. So the RB0 and the external interrupt occurred, it must be cleared in software. So like that, right? um, uh, uh, 0 RB0 in external interrupt did not occur. So when there is an RB0 interrupt occur, so what should be done? Then RBIF, RB port change interrupt flag. So at least one of the RB7 pins change state. A mismatch condition will continue to set the bit, right? So when there's an mismatch. So we'll take a look at those things later. We'll understand this one first, right? Then INTH, right? So of option register, right? So if you can remember in previous day when we are talking about the timers, we have talked about this option register. So why we need this option register is actually this INTEDG, that means interrupt H means. So if you can remember that I have talked about like rise in and fall in, or rise in edge and fall in edge. Rise in edge means, so we are going from 0 to 5 volts. That means but the first our voltage is 0, then we will go back to 5 volts. So 0 to 5. So that is rise in edge. Then if you are going from 5 to 0, it is fall in edge, right? Fall in edge. So therefore we can select it as well, right, in option register. Okay, so now we will take a look at this example. So a push button switch is connected to the external interrupt pin INT of PIC microcontroller. So it is connected to that RB01, right? Then when this button is pressed, And when this button is pressed, the microcontroller is interrupted and the ISR is executed. ISR means the interrupt service routine. That means it is like another process. The ISR toggles the status of port C for 1 second. Right? Toggles means it will 5 volts value will change to 0 volts, 0 volt values will change to 5 volts for port C register. Right? So in order to see them properly, I have connected these LEDs. Right? So here RB0 interrupt pin, we are connecting it to here. Right? This interrupt is connected in here, right? So what we are doing is actually first it is at 0 volts. So when this is not pushed, so these two are disconnected. So then this voltage will apply here, voltage in here, which is coming like this to here as 0 volts, right? 0 volts. And when I press this, so this will become like 5 volts. So 5 volts will apply it in here. Okay, then uh, so like this, right? um, any questions? Okay, first of all, what we will do is, right, so you can understand, in order to understand what is happening in here, right? So first of all, what you should do is, first of all, you have to make this design in Proteus, right? So um, I will give you a few minutes, right? um, like let's say I will give you like 10 to 15 minutes, right? So uh, within that time, can you make this, right? Can you make this design, right? Then we will go to the program, right? So remember the PIC is PIC 16F877A, right? So I will give you some time, right? I will give you some time, right? That will continue at 4:10, right? 4:10 p.m., right? So don't disconnect, right? Don't disconnect, right? Don't leave, right? So do this design by yourself by now, right? So this is very simple design, but there are a lot of things that you have to attach now. So therefore you have to spend some time. So I will give you like the time up to 4:10. Then can you just make this design, and then I will show you how to write the program as well, right? I will give you like 15 minutes, so we'll meet again at 4:10. So if you need anything, so I will be also available in WhatsApp as well, right? So anything, please send on the chat on WhatsApp also, you can send me, right? So I'll be here, right? I'll be here, but uh, so you need some time to do this, right? I'll give you that time, so we'll meet. um, I will not end this session, right? We'll be at this session, so do this one first, right? I have to resume recording, right? Okay. When there's an external interrupt occurs, so we have to clear it in software, or else the external interrupt did not occur. So that is what happening in int f. So it is interrupt flag, right? So we will clear the flag. Then we will put port C equal um, uh, this is the inversion of port C, which is 0 1 0 1 0 1. So like that, right? So I will explain this one. So this is our main method, and this is our interrupt method. So we will execute void main method first, main method at normal condition. So inside this while loop, what will happen is port C will have this value, right? So this is where we are working on. So since we have enabled interrupts, so when there's an interrupt occurs, what will happen is it will go to this method, right? It will go to this method. Then inside this method, what it does is it will toggle means it will equate port C value to the inversion of port C. That means inversion of this value. So then we will keep it that toggle for 1 second. Then after completing it, we will return back to main method. So then this will be executed continuously, right? So that's what happens. So there are two methods in here, So um, therefore like that we'll continue. So here option register int h means so it set rising edge trigger for interrupt. Then we will enable the global interrupt. Then we will enable the external interrupt, right? Then here we will clear the interrupt flag. Then we will invert the value of port C in uh, here for 1 second, right? Then it will return back to this, right? So something like that. So we can write anything inside this interrupt one, right? Interrupt method, right? But it will return again to the main method, right? So that's how the interrupt works, right? So what you should do now is, so we'll start okay, so we will start so you have to start a new project, right? New project, uh, new project, then name it, right? Then select pick 16F8 77A. So that is our pick. So then we will run it, right? Then we can put that thing inside the microcontroller, right? So can you try to do this now?